Okay, let's get started. So today, we're actually on pace to be ahead. So we're going to start Monday's stuff for you guys, and that starts with table of values 4.01. So, if you have something that looks like this, y equals 3x plus 2, then what we want to do with this is a lot of times we're going to want to look at that on a graph. And the graph is going to tell us useful information that the function wouldn't necessarily. So if we graph this, you guys should not know how to do this, but I'm going to do it just to show you what it looks like. So, two. So this is what this graph is going to look like. So it looks pretty steep in general. It goes up and down pretty far, and left and right, not a lot. So there are a couple different ways we can go after problems like this to graph stuff. And there are forms and formulas and things like that that make it a lot easier. But one of the most basic ways that doesn't really require any information at all is you can just plug numbers into this formula until you get out answers, and that'll tell you how to graph it. And that's kind of what we're going to go over in 4.1. 4.1 is called table of values. And table of values is you plug in x and you get out a y, and we graph those points. So if we say, okay, I want to plug -1 in, 0, and 1. This is just a list of things that I'm going to plug in, and this is just a list of things that I'm going to get out. So if I plug in -1, I'm going to get 3 times -1 plus 2, -3 plus 2. So I'm going to get -1. So if I graph that, I'm going to go down, left 1, down 1. So it crosses right here, which if I drew my line correctly, this line should go directly through that. So I'm just going to edit it a little bit like that. Try to make it go through all the right points. Okay, so now let's do 0. And what we're doing is we're saying, okay, on this x part of the graph, when x is 0, what is y going to be? So how far up are we going to be? So if we look at what we've already graphed, we expect this is going to be 2. So let's plug it in. So I'm going to plug in 0 for x. 3 times 0 is 0 plus 2. It's going to give me 2, just like we expected. So I'm going to put a 2. And then we do 1. So 3 times 1 is 3. And 3 plus 2 is 5. So we end up with 1, 5. So we found several different points on this graph, and it doesn't matter what we plug in, we're going to find a point. So if we plug in 1,000, then we do 3 times 1,000 plus 2 is 3,000 plus 2, or 3,000, that's 30,000 too. So 3,002. And if we go to graph that, that's going to be kind of difficult because we can't go over 1,000 and we can't go up 3,000. So either way, the point is that no matter what you plug in here, you're going to get something out that you can graph on this graph. And the table of values is all about choosing reasonable values, so that way when you graph them, it makes sense and you can actually put them on the graph. So number 1 on the assignment is very similar to the one that I just did. It gives you y equals -3 x plus 1. And it says, okay, draw or write a table of values and then graph it using the table of values. So what I like to do for my table of values is I plug in -1, 0, and 1, because these are always right around the x-axis. They're usually pretty small numbers. It's usually a pretty good bet that these are going to be good things to plug in. So I'm just going to go ahead and write these down. -1, 0, and 1. And then we're going to plug them in. negative 3x plus 1 equals y. Negative 3, negative 1 plus 1 equals y. So we get positive 3 right here, 4. So I'm going to put a 4 right here. Now we do 0. So now we plug in, we get 0 plus 1, which is going to give me 1. So I'm going to put that right there. And then now I'm going to plug 1 in. So negative 3 times 1 is negative 3, plus 1 is going to give me negative 2. So now we have 3 pieces of information, and you can use this information in the table to draw this graph. So when we draw the graph, we just plot each of these points, and then we have our line. So negative 1, 4. Remember, we go left and right and then up and down. 0, 1. And then 1, negative 2. So we draw our line through all these, and we are good to go. We have our graph. So just with this information, and just by blindly plugging in points into our equation, we can get out an actual line. And your assignment wants you to create a graph, and you can do it by hand, or you can use Google Docs or Word or GeoGebra or whatever. I think it's easier to do this by hand. Like if you guys printed out the worksheet, it's already got the graphs and stuff on it. So all you have to do is draw on them. So really your what you need to do is plug in any values. Again, like negative 1, 0, and 1, but any values will work, just to check and see if those are on a graph or to draw a graph with them. So a little later on, it asks if an ordered pair is a solution to an equation. And all an ordered pair is just 1, 2. And that's, it doesn't have to be 1 and 2, obviously. But that's the same thing as we have right here. This is just an ordered pair written in a table form. So it's asking if we plug this in, do we get this out? So let's give it a shot and see if that works. So 4x plus 3y equals 11. And it says, okay, is 2, 1 a solution? So what we do is we plug in 2 and 1. We plug this in for x and we plug this in for y, and we see what happens. So 4 times 2 plus 3 times 1 equals 11. So we multiply this out, and we're going to get 8 plus 3 equals 11, or 11 equals 11. So that is definitely true. So we can say, yes, in fact, this does work. That is something like your 8, 9, and 10 work on your work. That is actually number 8. There's a word problem about hiring an electrician. Let me copy it down here and then we'll work through it. Okay. So the question is, suppose you hire an electrician to install several electrical outlets in your house. The electrician charges $68 for materials plus $40 per hour for labor. So first thing we need to do is write an equation for this. So we say, okay, the electrician charges $68 for materials no matter how many hours he works. So that's not going to change depending on hours. So now we say, okay, 40 and let's say times hours equals something, total cost. So how much will the electrician charge if the job takes 2 hours? So what we do for this is we just plug in 2 for hours. And if we do this in a table of values style, then we draw our little table and we do hours and cost. So we're going to plug in 2 hours for the first one, and it looks like 5 hours for the second one. So plugging in 2, we get 40 times 2 plus 68 equals the cost. So that's 80 plus 68, which is 148. So it costs 148 for 2 hours of work. So if we call this 5 hours of work instead, then we do 40 times 5 plus 68 is going to give us 268, I believe. Yes. So it's going to cost us a lot more for 5 hours than it does 2 hours. And these are things that we can graph as well. This would be helpful for the electrician to kind of look at how much he makes per hour. If he actually drew this on a graph, he could be able to see, okay, well, if I work an hour and a half, this is how much I should charge. If I work for 15 hours, this is how much I should charge without having to work it every single time. He just kind of looks at the graph and says, oh, I go over 500 hours and then I go up and I say, okay, this is how much I should charge. So table of values, it's all about just plugging in numbers and then getting out something on the other side and being able to graph those as X and Y. So let's move on to 4.02, and hopefully we're going to keep it kind of short today because we are ahead. So I don't want to keep you guys if it's not necessary. Oh, it looks like I'm sorry, I skipped way ahead, guys. 4.01 is not the first section that we should have done this week. We should have done 3.04, it looks like, which is okay because these are actually very similar types of problems. I didn't realize that we were still in chapter 3. So let's move back to 3.04 and go over that. Let me get to the work real quick, and then we'll go over it. Okay, so like I said, this is very similar stuff. If you can do table of values, you can do 3.06. It just makes it a little clearer what you're looking for and when you like what it wants. So a problem that it might give you would be something like this. I'm gonna paste it down here in just a second. Okay, so something like this. It asks for, it gives you a function and says, okay, what are your x values, what are your y values, and what are your ordered pairs? Well, x values are things that you can make up. And like I said, I like 0, -1, and 1. So if we plug that in, I'm just going to write them out here. And I'm going to do them in -1, 0, and 1. Okay, so now we work it. We say f of x or y, either one, equals -x minus 4. -x minus 4. So this is function notation, if you'll remember, and all it means is whatever we plug in right here, it goes right here. So if we do f of -1, we get -1 minus 4. All I did was take this -1 and I put it everywhere that there was an x. So what we get over here is y equals -1 minus 4. Same thing right here, just slightly different way of writing it. So we work it out, and we're going to get +1 minus 4, or -3. So in our y value right here, we're just going to put -3. It's the same process as the table of values. It's just it wants it in a different format here. So what this means is this is our x and this is our y. So when we write this, we write it as an ordered pair. We do a parenthesis, we do our x, and then we do our y. So that is how you write the ordered pair after you've found x and y. And x you can just make up, y you find using x, and then the ordered pair you put them together. And it's just the way of saying here's both of them included together. So if we plug in 0, -x minus 4. So I'm going to do -0 minus 4. -0 is just 0. You can't really have a -0. So we're going to have a -4. So if I scroll back up, I'm going to put -4 right here in the 0 column. And then I'm going to have 0, -4. And then if we plug in 1, -x minus 4, -1 minus 4, that's going to give us -5. So -5 for our y value, 1, comma, -5. So that's all it wants you to do for graphing functions. Now that you have these ordered pairs, you just put them on the graph, just exactly like we were doing before. So if I copy these guys and bring them down, so let's put them on a graph. Okay, so -1, we go left first and then down. So -1, 1, 2, 3. That's because they're both negative. Now we do 0, -4. So 0, -4. And then 1, -5. So we now have a line that we can draw. So if we do that, it will go just like that. And it'll go up all the way. And it'll go down all the way, as far as you can draw it. So, I mean, all it takes for you to actually get the line is just putting these on the graph and then drawing a line through the line that they make. So we have absolute value functions as well. An absolute value, I don't remember if we've gone over this or not. It just makes whatever's inside it positive. So number 2 on 3.04 is going to be this problem. And these are absolute value bars. And all that means is distance from 0. So whatever is inside these guys gets made positive at the end. So we say, okay, we're going to plug in 0, -1, and 1. So we plug in -1, -1 plus 4. We're going to get 3. So now we plug in 0. We're going to get 4. I just keep updating my little table. And now I plug in 1. And it's going to give me 5. So this is my y values. This is my x values. And then my ordered pairs are -1, 3, 0, 4, and 1, 5. So this is filling out that table, and then you just go plot each of these points and draw a line through them. That's all that there is to 3.04. It's just finding these points and then putting them in the table like they want it. So let me look and see what other section we have. Okay, so what we will do is we will call it quits for today since we are ahead. And we will talk about 3.05 components of functions tomorrow. Or I'm sorry, Monday. So I will let you guys go, and y'all have a good Friday. Yes.
I'm already there. Just a little late. I was not feeling good this morning.
You're good, Amari.
Thanks.
So Jeremy, if you want to stay on and we can go over the function stuff, then that's fine. But everybody else is free to leave.
Have a good day, Mr. Albright.
You too.
Have a good weekend.